Brine shrimp babies. Saline. What do they have in common? To be honest, I have no idea. Through my lab, I hope to find out how the levels of saline in the water affect the hatch rate of brine shrimp. You're probably asking yourself, what on earth is a brine shrimp? And I'm so glad you asked, because I made answering that question my personal mission. I mean, look, I'm taking notes and everything. Brine shrimp, or also known by their less politically correct name, sea monkeys, are really weird. Apparently, they found the recipe for success because these little nightmare feathers come to life have been around since the Triassic period. It is baffling how successful they've been, considering the fact that they need to be upside down to swim. Brine shrimp are filter feeders, meaning they're one of the lowest rungs in the food chain. They serve as food for things like fish, birds like flamingos, grebes, and avichets. I really hope I pronounced those right. And I kid you not, water boatmen. Wait, no, I'm sorry, these water boatmen. If you happen to eat a brine shrimp, they serve as a great source of protein, omega-3 fatty acids, and contain 9 amino acids that our body needs but can't produce. Brine shrimp are also great indicators of water quality. They die fairly easily when exposed to things like pollutants or just poor water quality in general. This, again, makes it really funny how long they've lasted. Female brine shrimp can either lay normal shrimp eggs, however you define that, or cysts, which are those shrimp eggs that come with a corian coating. This coating allows the larvae inside to live in pretty much any condition safely in and or out of water for up to 2 years, which is insane. Crazier fact, brine shrimp are a cornerstone of the Utah economy. Yeah, you heard me correctly. Brine shrimp bring Utah a total of $60 million every year. I'm sorry, what? Billions upon billions of brine shrimp live in this place in Utah called Great Salt Lake, which, spoiler alert, does not bode well for my hypothesis. Farmers will go into this lake, scoop out as many cysts as they can, put them on their boat, process them, and then sell them to the general public and world and rake in a bunch of money. This is not exactly where Utah gets all of its money from, but $60 million is still a lot of money. Final fun fact about brine shrimp. They make for a really great lab experiment. Being the scientist that I am, I'm going to drop my hypothesis before we get into any part of my experiment. Based on my limited knowledge of brine shrimp, I deduce that any sort of change in the water from the oceanic normal of 35 parts per thousand would result in a negative change in the amount of brine shrimp hatched due to their sensitivity. Most newborn creatures are very sensitive. Drastically changing what is basically their atmosphere would most likely hurt its overall health/hatch rate. Now let's see if I'm right. First things first, I need a game plan. The most obvious first step is going to be gathering up all of my materials that I need for this experiment. Luckily for me, everything I need is going to be located in my lab, but for those of you who want to recreate this at home, the things you're going to need are a salinometer, tap water, and seawater. I would recommend about 2 liters of seawater just for safety. You're going to see why in a bit. Petri dishes, a pipette, a burner, dissector scope, and brine shrimp eggs, obviously. To really get an idea of how the levels of saline in the water affect the hatch rate of brine shrimp, we need to include a sample of heavily salinated water. Now, getting this water was a very intricate process that I'm going to guide you through so you know how to do it at home. Get your notebooks out. No, I didn't go to somewhere like Great Salt Lake to find it, and no, I didn't combine a bunch of chemicals to make artificial water. What I did, stick with me here, I boiled it. So all you need to do to raise the level of saline in your ocean water is boil it. When we boil it, we evaporate some of the water that's inside, which has the water tell the saline, I'm going to grab some milk and I'm not going to come back, which leaves the same amount of saline in less water. This process takes a long time, just fair warning. When I was doing this, I had to sit and watch water boil for 45 minutes. This was the scientific equivalent of watching paint dry. I then proceed to spill all the water I need on the table, only saving a fourth of what I needed, which was the scientific equivalent of watching paint dry, and then some dude throws a fresh bucket of paint on the wall you're watching dry. So after another 30 to 40 minutes of watching water boil, I finally had all the water I needed to conduct my experiment. Day 1 was spent putting brine shrimp eggs into their environment. I had 3 separate samples of water, which I put into 3 dishes each. Samples A are tap water, or 0 parts per thousand. Samples B are seawater, or 35 parts per thousand. And samples C are 70 parts per thousand, or in other words, the saline-based concoction I cannot hold for the life of me. Once the trays were ready, I introduced our sensitive little upside-down swimming Utah money-making shrimp. For the sake of my own sanity, I only added 1/100 of a gram of shrimp eggs. I can already hear your pushback. only 1/100th of a gram? What kind of bum skips out on brine shrimp eggs? And valid criticism. But keep in mind that 1/100th of a gram of brine shrimp eggs is equal to hundreds or thousands of brine shrimp. So just keep that in mind. Here's the dishes after placing the brine shrimp eggs inside. Because brine shrimp only take 24 to 36 hours to hatch, we only need to record the results for 2 days to get our desired outcome. It's been about 24 hours since we introduced the briny babies to their environment, and call me a scientific genius because I nailed that hypothesis. Look at what we have. All 3 samples for A and C have nothing but eggs and corpses, which is a really morbid thing to be excited about. Samples B, however, are teeming with life and briny babies. To avoid the pain of hours upon hours of counting, and get a general idea of how many eggs, shrimp, and dead shrimp there are in the water, what we can do is take a pipette, stir up each dish, suck up the same amount, put it under a dissecting scope, and then count from there. We go from counting microscopic moving dots we can barely see to counting moving dots we can barely see, because looking at a scope is difficult. After what was pretty much the scientific equivalent of a Where's Waldo, but everyone's Waldo, here are the average results of the samples. Surprisingly, but not surprisingly to me though, because I'm smart, awesome, and totally called it, B had the highest average of living briny babies of about 58.67, or in other words, not 0. A holds the title for most shrimp eggs, dwarfing B's 14.3 and towering over C's 9.3, with a count of 30.67 eggs on average. A samples also hold the lead in most shrimp corpses, a phenomenal achievement, with a record-breaking number of 12, or in other words, not 0. C is just falling behind on all regards, with only having 9.3 eggs on average, which is a concerning number considering that there are only eggs in the petri dishes. Really quickly, here are the unaveraged charts for A, B, and C for you to look at. But anyways, back to the eggs in C. The number could be low for sample C because when I placed the eggs inside, they seemed to clump together, even after stirring, which was odd. But I'm sure my hypothesis holds up perfectly, because I'm clearly the best at science. Well, in a shocking twist that no one saw coming, C samples are now bursting with life. That's great. So rinse, repeat, stir, pipette, count, and count some more, and our new averages look something like this. A still holds the record for best shrimp graveyard, which is as impressive as it is morbid, bumping its original 12 up to 87.67. In the span of one night, much like Santa on Christmas Eve, C samples not only shot up in life, but matched B's average of 48 living briny babies. While B had a lot more eggs on average, holding its 25.7 to C's 6, it also had less dead shrimp, with B having no shrimp corpses, and C having an average of 0.3, or in other words, a singular dead shrimp. Once again, here are the individual graphs for each sample. So now we have all the data we need to answer the question how the levels of saline in the water affect the hatch rate of brine shrimp. Based on my findings, here's my report. Starting from about 35 parts per thousand, the more saline introduced into the water slows down how fast the brine shrimp hatch. When we look at the data, while on day 1, B samples had some brine shrimp swimming around after 24 hours, as time went on into day 2, C sample matched the amount of living brine shrimp, meaning they took more time to hatch. So, that was my lab project. I hope you enjoyed. Dr. Viviani said to try and tell a story with our lab, and I tried to tell a comedy, even though the brine shrimp truthfully faced more of a tragedy. Let me know if you have any questions.